There was a violent thermal explosion at the Yellowstone supervolcano, and researchers are now anxiously monitoring the activity of the magma underground. Could an eruption of the monster volcano be imminent? And what would that mean for the USA and the entire planet? We're going to take a close look at all of this, so make sure you stick around until the end. Welcome, everyone! What happened again at the Yellowstone volcano? On July 3rd, there was an impressive hydrothermal eruption at the famous Diamond Pool. And the whole thing was captured by a new surveillance camera. A several-meter-high jet of steam shot out of the pool, hurling mud and rocks into the air and even flooding one of the seismometers. Let me know in the comments what your first reaction would have been if you were standing there as a visitor. Would you grab your stuff and run away, or would you pull out your phone and start filming? I'm curious to hear. And by the way, if you never want to miss any news about the world's volcanoes again, make sure to subscribe to the channel. It doesn't cost anything, you'll never miss a new video again, and it really helps me out. Thank you so much, everyone. Yes, it was already the third explosion of this kind in just a few weeks, and understandably, researchers are now a bit concerned. Even though these events don't directly indicate an imminent volcanic eruption, new studies show that there is mobile magma beneath Yellowstone. And what researchers have recently discovered there tells us a lot about a potential eruption of the supervolcano. The Yellowstone supervolcano is one of the largest and most active volcanic systems on Earth. It is located in Yellowstone National Park in the northwest of the USA and is notorious for its gigantic eruptions in the past. Another major eruption would have devastating consequences. It could bury entire regions in the western United States under meters of ash and trigger global climate changes. Here you can see a map where researchers have marked the so-called death zone and the ash area of a worst-case eruption. That does make you feel a bit uneasy. Such an eruption would have dramatic consequences for the weather worldwide. Such a worst-case scenario is, of course, extremely rare, and that's exactly why researchers are studying the magma system so intensively to better understand possible early warning signs. And in the course of this, a research team from the US Geological Survey has discovered something that fundamentally changes our understanding of the Yellowstone volcano and also casts the probability of an eruption in a whole new light. Under the leadership of seismologist Ninfa Benying, the scientists conducted a comprehensive magnetotelluric survey of the Yellowstone caldera. That might sound complicated at first, but it's actually a pretty clever method because it measures fluctuations in the Earth's magnetic and electric fields to detect what's beneath the Earth's surface. This method is especially well suited for detecting molten rock, that is, magma. And what the researchers discovered in the process is truly remarkable. The magma chambers that supply the supervolcano with energy appear to be shifting toward the northeast of the caldera. Based on the volume of rhyolitic melt beneath the northeastern part of the Yellowstone caldera and the direct connection of this region to a heat source in the lower Earth's crust, we suspect that the center of future rhyolitic volcanic activity has shifted to the northeastern part of the Yellowstone caldera, the scientists write in their study. But what does that actually mean? And how dangerous is it now? To understand that, we need to dive a bit into volcanology. Yellowstone isn't just a big volcano. It's a supervolcano, one of the largest volcanic structures on the planet. In the last 2.1 million years, it has experienced 3 massive caldera-forming eruptions. These massive eruptions left behind huge craters when the magma chambers emptied and the Earth's crust above them collapsed. Between these mega events, there were also smaller eruptions from time to time, the last significant one about 70,000 years ago. So you might think that it's about time for another one. Researchers have now discovered that there are at least 7 different regions with high magma content beneath the Yellowstone caldera. Some of these feed others, and they are located at depths between 4 and 47 kilometers below the surface, all the way down to the boundary between the Earth's crust and mantle. What's especially interesting is that the largest amounts of magma were found in the northeast of the caldera. It appears that huge reservoirs of basaltic magma are located in the lower crust here, which in turn heat and sustain chambers of rhyolitic magma in the upper crust. But wait a minute, basaltic and rhyolitic magma, what's the difference? They're basically the 2 main characters in our underground volcanic drama. Basaltic magma contains little silicon, but a lot of iron and magnesium. It's relatively fluid and can therefore rise easily. Rhyolitic magma, on the other hand, is rich in silicon and, in terms of its chemical composition, corresponds to the deep magmatic rock granite. It's viscous, thick, and moves only slowly. And this is where things get dangerous, because this sticky consistency makes it harder for gases to escape. Imagine you're cooking a thick pea soup or something, and the bubbles can barely make it to the surface. It's the same with rhyolitic magma. And when the pressure gets too high, it goes boom. The result is an explosive eruption, but in this case, it's not just soup splattering in the kitchen, it's a bit more intense. An interesting aspect of the study is also the relationship between the different types of magma. The researchers suspect that the rhyolitic magma chambers have to cool down completely before basaltic magma can intrude. This means that we're observing a complex interplay between different processes that take place over long periods of time. And the caldera-forming eruptions in Yellowstone were caused by exactly such rhyolitic magma chambers. And now, the researchers have discovered a reservoir of rhyolitic magma in the northeast of the caldera, whose estimated volume, brace yourselves, lies between 388 and 489 cubic kilometers. For comparison, that's almost 10 times more than in the regions to the south, west, and north, where previous eruptions took place. So if an eruption were to occur in this region in the northeast of the caldera at some point, then things would get really, really unpleasant. Because according to scientists from the US Geological Survey, this amount of magma is roughly equivalent to the amount that was hurled to the surface during the massive Mesa Falls eruption 1.3 million years ago. That eruption was so powerful that it devastated a gigantic area and spread ash over large parts of North America. It released around 280 cubic kilometers of ash and rock. So, theoretically, we're talking about an apocalyptic event like that here. So should we start stockpiling toilet paper already? There's no reason for immediate panic, because researchers have also found that the magma is stored in separate areas with low melt fractions. That means the reservoirs are probably not capable of erupting at the moment. Most of these individual reservoirs contain amounts of magma that would only result in smaller eruptions after the caldera formed. But still, the shift of the volcanic center to the northeast of the caldera is an absolutely significant development, because it shows us that even a seemingly stable system like the Yellowstone supervolcano is dynamic and changes over time. And even though an eruption like the Mesa Falls event isn't expected in the short term, in the end, it's of course not a question of if, but only of when we'll see a major explosion at Yellowstone. And this new research is helping us better understand exactly where such future volcanic activity is most likely to occur. And this discovery not only gives us insights into Yellowstone itself, but also into volcanic systems worldwide, because the behavior of magma flows can be applied to other volcanoes as well. So these findings could even help us better predict eruptions in other places and potentially save lives. Of course, the research continues. Scientists will continue to closely monitor Yellowstone in order to record every change and deepen our understanding of this giant beneath the American landscape. And with every new discovery, we get closer to answering the big question: when will the sleeping giant awaken again? It's crazy, the amount of magma down there, isn't it? But that's not all. NASA has actually developed a plan for how to prevent a supervolcano eruption. And the plan is so crazy, it's actually brilliant. Let's take a look right away. But first, I wanted to quickly point you to my space shop, where you can find plush planets, black hole cafe items, and the shirts from the videos. Just click here on the QR code or the link in the pinned comment and stock up on nerdy stuff. Every order really supports my work. Alright, now you'll find out how NASA wants to kill two birds with one stone. In the last 2 million years, there have been 3 known supervolcano eruptions in the Yellowstone area. The most recent one happened about 640,000 years ago. Let's do a little math. 3 eruptions in 2 million years, so roughly 1 eruption every 600,000 years, the last one roughly 600,000 years ago. Oh. Statistically speaking, Yellowstone would actually be next in line soon. And by that, I mean soon in geological terms. Don't worry, folks, our existence probably won't be ended by a supervolcano eruption, but rather by an all-powerful artificial intelligence. But hey, there's always something, right? Nevertheless, we can see that Yellowstone will erupt again at some point. It's just a question of when, not if. So it makes sense to start thinking now about what we can do about it. And in fact, NASA scientists have come up with an absolutely insane plan. A team from NASA's Jet Propulsion Laboratory looked into the possibility of harnessing the geothermal energy of the Yellowstone supervolcano while also reducing the risk of an eruption. Their plan is to pump water into the magma reservoir beneath Yellowstone National Park to draw out the heat and lower the temperature inside the volcano. That sounds exactly like the beginning of a disaster movie. Basically, the idea of harnessing the geothermal potential of the supervolcano while also reducing the risk of an eruption is brilliant. Because the amounts of energy produced there are, of course, immense and, with the right technology, could probably solve all our energy problems. Which, of course, would mean that such a technology would be provisionally banned in Germany. But anyway, what exactly have the NASA researchers come up with? Their concept is based on the idea, as already mentioned, of pumping water into the magma reservoir beneath Yellowstone National Park. This water would draw heat out of the magma system, which would then lower the temperature inside the volcano. The heated water could then be pumped back to the surface and used to generate geothermal energy. The continuous extraction of heat would, over time, make it less likely for the volcano to erupt. Sounds easy, and the process itself really isn't that complicated. Basically, you can say that such a geothermal power plant works in 4 steps: water injection, steam production, turbine drive, and condensation. The water is injected into the magma reservoir, heats up, and rises as steam. There, it is directed to a turbine, which produces electrical energy. After that, it cools down in a condenser and is then fed back into the geothermal cycle. Absolutely brilliant. So, let's get started. Let's build the thing. Unfortunately, there's one tiny little problem. To cool Yellowstone down enough so that it won't erupt anymore, we would have to extract, and now pay attention, 20 gigawatts of energy. How much is that? Well, NASA researchers calculated that we would have to run the geothermal power plant for about 16,000 years to do that. That's really thinking long-term, and carrying out the project would also require significant technical challenges and investments. Because to get water deep enough toward the magma chamber, shafts up to 10 kilometers long would have to be drilled. The heat is then supposed to be extracted from the underside of the magma chamber. Why so complicated? Because if you simply drill straight down into the magma chamber from above, you risk triggering a volcanic eruption. The lead researcher, Brian Wilcox from the Jet Propulsion Lab, says there's a risk of triggering an eruption, which is exactly what you want to prevent. If the magma chamber is drilled from below, it prevents the heat from rising up from underneath and ever reaching the top of the chamber, where the real threat lies. So we're talking about a gigantic mega project here, one that could only be accomplished across multiple generations. After NASA's Jet Propulsion Lab developed the idea, no concrete steps have been taken toward actually implementing it so far. Then, in October of last year, a new paper was published that laid out in more detail how energy could be tapped from Yellowstone. And the numbers are truly staggering. The costs would amount to $3.5 trillion. With over 11 quadrillion watt-hours of energy output, the project could supply the entire United States. And just like NASA, the new paper also concludes that the supervolcano would be cooled down so much that it would never erupt again. So far, these are all just proposals and theoretical plans, but I think someone should work on securing funding for the project and actually get it started. Our descendants would surely thank us for it. Because as Dr. Brian Wilcox says, Yellowstone explodes about every 600,000 years, and it's been about 600,000 years since the supervolcano last erupted, which should make us get up and take action. Feel free to share your opinion in the comments. Should we take on the Yellowstone power plant megaproject? Even if it's expensive, sounds like science fiction, and would take a super long time? Or should we rather focus our energy and money on other projects? I'm really curious to hear what you think. Scientists can get really creative when it comes to the survival of humanity. If you liked this, feel free to give it a thumbs up. Maybe we can hit 5,000 likes for this video, and then the YouTube algorithm will show it to even more people. And now, let's stick with the latest developments around Yellowstone, because researchers haven't just studied magma movements, they've also made fascinating discoveries about past eruptions. The Yellowstone Volcano Observatory has published its latest annual report, and it's packed with interesting stuff. Yeah, if you Google Yellowstone these days, you almost only find stuff about the Yellowstone series with Kevin Costner. Let me know in the comments if any of you know it. My wife always watches it, and I kind of watch along with one eye. But I dug through all those Kevin Costner pictures and found the latest exciting info about the Yellowstone supervolcano for you, because the new annual report from the Yellowstone Volcano Observatory, or YVO for short, has just been published. And on top of that, volcanologists have made some truly explosive discoveries about past lava flows and a potential eruption. So, buckle up. First, the basics. The Yellowstone supervolcano is located in northwestern Wyoming and stretches into parts of Montana and Idaho. The Yellowstone caldera, a gigantic volcanic depression, was formed about 631,000 years ago by a massive eruption of rhyolite magma that spread ash across large parts of North America. That eruption was truly something else and is one of 3 catastrophic eruptions that have occurred in the last 2.1 million years. So Yellowstone really belongs to the Champions League of dangerous volcanoes, basically the volcanic creme de la creme. By the way, this is how AI imagines the volcanic creme de la creme. The caldera itself is a complex structure that has been shaped by repeated volcanic activity over thousands of years. Since the last major eruption, 28 smaller rhyolite eruptions have further shaped and filled the interior of the caldera. And these eruptions manifested themselves through lava flows that continue to shape the landscape of Yellowstone to this day. Unfortunately, I've never been there, but it's definitely on my to-do list to travel to the USA someday and produce a documentary about the Yellowstone volcano on site. Feel free to let me know in the comments if you'd be interested in that. The more people want it, the more motivated I'd probably be to make my way from Cologne to Wyoming. There would be plenty of reason, because volcanologists have now discovered something crazy that has fundamentally changed our understanding of lava flow eruptions in the Yellowstone caldera. Until recently, scientists assumed that the lava flows during past eruptions occurred over long periods of time. But new data suggests that several lava flows happened simultaneously or in short intervals. Researchers at the Yellowstone Volcano Observatory have dated lava flow eruptions from a period between 160,000 years ago and 70,000 years ago and found that these occurred in tight clusters. And this suggests that instead of isolated events, multiple lava flows erupted simultaneously from different volcanic vents within the caldera. According to recent research, the 22 rhyolite eruptions known as the Central Plateau member rhyolites occurred in 5 brief episodes. Each episode could have lasted up to 400 years, and these episodes, during which 2 to 9 lava flows erupted simultaneously, show that intracaldera eruptions, that is, smaller eruptions within the long-established large caldera, are dramatic events, much more dramatic than previously thought. And these new findings, in turn, have significant implications for assessing the eruption probability of the Yellowstone supervolcano. On the one hand, they show that intracaldera eruptions are more intense and complex than previously thought. On the other hand, they suggest that the long-term eruption rate in Yellowstone could be lower than assumed. If the Central Plateau member rhyolites were formed by 5 events instead of, as previously thought, 22, then this means that eruptions are rarer, but more intense. Or in other words, it doesn't blow often, but when it does, it's lights out. Geologist Mark Stelton from the US Geological Survey puts it this way: intracaldera eruptions are more dramatic than previously assumed. Instead of isolated events where a single lava flow erupts, intracaldera eruptions seem to involve multiple eruptions that could occur simultaneously in different parts of the caldera. And what does the new annual report say about the likelihood of an eruption? That's of course what American geologists are monitoring with the utmost care, because a worst-case eruption would devastate large parts of the United States. Here on this map, you can see how large the death zone and the ash area would be. That would be bad, and that's why monitoring is essential. One of the most important aspects of monitoring the Yellowstone volcano is the analysis of seismic and geodetic data. Every year, between 1,000 and 3,000 earthquakes are recorded in the region. Most of them are so small that they can't be felt, but these quakes are closely linked to volcanic activity and thus provide clues about possible changes in the magma reservoir beneath the caldera. And although the new findings suggest that past eruptions were more intense, there is currently no evidence that a new eruption is imminent. According to the YVO, the rhyolite magma chamber beneath Yellowstone currently consists of only 5 to 15% molten and viscous material, so there probably isn't enough magma under the caldera for an eruption. So at the moment, Yellowstone simply doesn't have the firepower for a volcanic apocalypse. Of course, smaller eruptions can never be completely ruled out. It's always possible that Yellowstone could have a smaller eruption without destroying North America and beyond. About 70,000 years ago, rhyolitic lava flows erupted from the supervolcano, and while this eruption did change the geology of the southwestern Yellowstone National Park, it wasn't exactly catastrophic for life on the planet. And even though the magma chamber is currently providing reassuring data, a major eruption can never be ruled out 100%. Science journalist Tom Hale writes, "Still, anything is possible. The surrounding geological layers could collapse, or the volcanic chambers could receive a new injection of magma, reviving the monster from below. If a major eruption were to occur in Yellowstone today, its effects would be felt all around the world. Large parts of Montana, Idaho, and Wyoming would be covered by pyroclastic flows of hot gas and volcanic material. Estimates vary, but some suggest that up to 90,000 people could be killed instantly, and the climate of the entire planet would change drastically. Most likely, a massive global cooling caused by volcanic aerosols in the atmosphere would follow. But if you're already getting scared and thinking about taking out volcano liability insurance, here's a reassuring fact from the new annual report of the Yellowstone Volcano Observatory. In addition to seismic monitoring, scientists use GPS and INSAR data, that stands for Interferometric Synthetic Aperture Radar, to measure ground deformation. Because the more the terrain deforms, the more volcanic activity there is. And these data show that the Yellowstone caldera is currently subsiding by 2 to 3 centimeters per year. Volcanologists consider that to be rather little, so for that reason as well, we can assume that the magma chamber currently isn't experiencing any significant accumulation of magma that could lead to an eruption. The insights into Yellowstone's past definitely help us to better assess its future. But Yellowstone isn't the only supervolcano that worries scientists. There's another candidate in the US that many people haven't even heard of, the Valley Caldera. And it's showing much more disturbing activity than Yellowstone. A restless rumbling underground, seismic activity, and a region that's slowly deforming. Are these the signs of an impending supervolcano eruption? We're not talking about the well-known Yellowstone, but about another American supervolcano, the Valley Caldera in Eastern California. Never heard of it? Well, it's about time, because this supervolcano is highly active and has the potential to throw the world into serious chaos. The Valley Caldera consists of an impressive crater east of the Sierra Nevada. Hence the name, because a caldera is a round depression created by volcanic activity. The Valley Caldera is the second largest caldera in the USA after Yellowstone and thus one of the largest calderas on Earth. Is calderon the correct plural? Calderii? Calderii? This present-day caldera and the distinctive landscape were formed by a massive eruption 760,000 years ago. At that time, 1,400 cubic kilometers of ash, pyroclastic material, and lava were ejected. This led to a huge ash deposit that covered large parts of eastern California and reached all the way to Nebraska. I mean, just look at this area. This eruption created a depression covering 540 square kilometers, which is sunk 300 to 1,000 meters compared to the surrounding region. That gives you some idea of just how apocalyptic this eruption must have been. Alright, but now some of you might be saying, yeah, so what? That was hundreds of thousands of years ago. Who cares? The US Geological Survey runs its own observatory, the Long Valley Observatory, or LVO for short, to monitor the caldera's activity. For a long time, it was assumed that the supervolcano had entered a lunar period of dormancy and that there was no real major threat. But just like in every disaster movie, that was, of course, deceptive. Over the past several decades, the geological conditions have already been changing. Seismic activity has gradually increased, and in recent years, the whole situation has taken on worrying proportions. Geophysicist Ashton Flinders from the US Geological Survey says, "Our data suggests that there have been significant magma inflows since the last eruptions 760,000 years ago. This means that the supervolcano may not be as inactive as previously thought. And I don't know about you, but that does make me a little uneasy. Because after just hearing how massive the eruption was 760,000 years ago, it's clear that another eruption of that magnitude, with the release of ash, would have global consequences. The southwestern United States would of course be hit the hardest, but globally, air travel would also come to a standstill and there could even be climatic changes." Geophysicist Birger Gottfried Lohr from the German Geo-Research Center agrees, saying, "If the eruption were to be of a similar magnitude as 760,000 years ago, we would have to expect global consequences." So it's high time to get to the bottom of the increased activity of recent years. Is an eruption looming here? Or could there be other causes? A research team led by the aforementioned geophysicist Ashton Flinders has taken a very close look at this. Of course, I've linked their published paper for you below the video. They see two possible processes inside the volcano as potential causes for the recent uplift of the Earth's surface. Possibility 1. The liquid magma core is approaching complete solidification. This would be accompanied by the expansion of the cooling rock, which would in turn raise the Earth's surface. So that would be the optimistic scenario. According to this, we are simply witnessing the volcano's slow calming down, and an eruption would be unlikely. But unfortunately, there's also a second possibility. Inside, pressure is building up due to gases and liquid magma that can't escape. This pressure could be released in an eruption. Well, so which scenario is it? Please let it be option 1. Please let it be option 1. Unfortunately, it's more likely option 2. Gem. The research paper states, although we cannot distinguish between magmatic intrusion and the mobilization of exsolved fluids as the driving force behind the recent uplift at Long Valley, we can conclude that the mid-crustal reservoir is still rich in melt. Geologists tend to express themselves in complicated ways. That means they couldn't determine whether that's the cause of the recent seismic activity. But they did find out that there's still a whole lot of magma bubbling inside the volcano system. There's no sign of inactivity or a dormant phase, because it goes even further. And now comes the kicker. We estimate that the reservoir currently contains enough melt to support another supervolcano eruption comparable in size to the caldera-forming eruption 6,000 to 7,000 years ago. So, the volcano is still active, contains a huge amount of magma, and the total mass of this volcanic material is also large enough to cause an apocalyptic eruption. Those are exactly the kind of results you hope for in your research work. But of course, that doesn't mean a major eruption is about to happen right outside our door. To better assess the danger, many more factors would need to be examined in detail. Further drilling is planned to find out whether the molten magma is collected in one large reservoir or spread out across several smaller ones. An eruption also depends on whether the reservoir continues to be supplied with new magma from the Earth's interior. And if you're not worried enough yet, here's something else. Near the Long Valley Caldera, there are other extremely young lava fields along the nearby Mono-Inyo craters chain. So, completely independent of the activity of the Long Valley Caldera itself, there are other magma pockets in the area, and those alone are already active enough to, for example, cause strong earthquake swarms. Accordingly, the entire Long Valley Caldera region is classified by the US Geological Survey as a very high threat, the highest risk category used by the agency. So, it remains exciting, and for now, the only option is to continue monitoring the seismic activity. It's really remarkable how many volcanic time bombs are ticking in the USA. But not all volcanoes are on land. Deep beneath the ocean surface off the US west coast, a completely different world full of volcanic activity is bubbling away. One of these underwater volcanoes is set to erupt this year, the Axial Seamount in the Pacific. The Axial Seamount, an underwater volcano about 480 kilometers west of the US west coast, is currently making headlines in the world of geology. And not because it produces especially beautiful bubbles or because Nemo is vacationing there. Although, that could be the case too. No, scientists have recently predicted that this volcano will erupt this year. Now you might be asking yourself, so what? Why should I care about a volcano underwater? Well, this volcano is highly interesting for several reasons. First of all, it's big. It rises 1.1 kilometers above the seafloor. By the way, here's a little guessing question for you. How tall, in kilometers, do you think the largest underwater volcano in the world is? Take a guess and write your answer in the comments. The solution will be shown at the bottom near the end of the video. I'm curious to see who among you gets the closest. Yes, the Axial Seamount is one of the most active underwater volcanoes in the world. You could say it's the class representative of underwater volcanoes. Always active, always bubbling away. But what really makes it special is its regular eruption pattern. Imagine you had a roommate who reliably freaks out every few years and trashes the living room. Usually happens after the 5th gin and tonic at the house party. That's pretty much how the Axial Seamount behaves. It has erupted several times in recent decades, most recently in 1998, 2011, and 2015. This regular behavior makes the Axial Seamount a favorite among scientists. Because while most volcanoes are unpredictable, like a 3-year-old after too much sugar, the Axial Seamount is comparatively predictable. That's partly because it's the most closely monitored underwater volcano in the world. Imagine you had a webcam, microphones, and motion sensors set up in a child's room. That's how researchers observe this underwater volcano. The scientists use a whole range of cool gadgets for this. For one, there are pressure sensors on the ocean floor. They measure how the volcano swells and contracts. Because, like a big balloon, it slowly fills with magma before it erupts. In addition, autonomous and remotely operated underwater vehicles are used. These small submarines buzz around the volcano and collect data. It's a bit like an armada of tiny Starship Enterprises observing an exotic planet only underwater instead of in space. And not a planet, but a volcano. And not a Starship Enterprise, but a submarine. Forget the comparison. The coolest instrument for research might be the SOSUS system. That guy's had a bit too much to drink. SOSUS stands for Sound Surveillance System and was originally intended to track Soviet submarines during the Cold War. Today, scientists use the system to monitor the volcano's seismic activity. It's kind of like listening to the volcano with a giant stethoscope. And what the researchers are hearing leads them to conclude that the next big event will happen this year. The prediction for the next eruption is based on several factors. For one thing, since its last eruption in 2015, the volcano has swelled up quite a bit again. By now, it has pumped up to over 95% of the threshold it reached before the last eruption. It's like blowing up a balloon, and it's already almost as big as it was the last time it popped. Or like me after my 10th piece of pot roast at Christmas dinner. You'd start getting cautious too, wouldn't you? In addition to the inflation of the volcano, scientists have also detected a significant increase in seismic activity. The seafloor is shaking. According to the American Geophysical Union, AGU, there are now hundreds of earthquakes per day, with swarms of more than 500 a day. Based on these observations, and assuming the volcano will erupt once it reaches the 2015 level, scientists are now predicting an eruption before the end of 2025. That might still sound far off to some of you, but in geological timeframes, that's basically tomorrow morning. Now you might be wondering, okay, cool, but what actually happens if it erupts? Imagine shaking up a bottle of Coke and then dropping a Mentos in. It's kind of like that, just way bigger. When it erupts, hot magma pours out of the volcano and meets the cold seawater. This leads to explosive steam formation and can hurl large amounts of volcanic material into the water column. The last eruption of the Axial Seamount in 2015 was pretty impressive. The volcano produced a lava flow that was almost 2 kilometers wide. It's kind of like if your entire neighborhood suddenly got flooded with lava and the game "The Floor is Lava" finally became real. During the eruption, the seafloor sank by more than 2 meters. But don't worry, there's no direct danger for us land dwellers. The Axial Seamount is too deep and too far out at sea to trigger a tsunami or anything like that. That was also confirmed by Jeff Beeson, a geologist at Oregon State University. So you don't need to put your surfboards away just yet. So why are scientists so excited about the upcoming eruption? Well, the Axial Seamount offers a unique opportunity to learn more about underwater volcanoes and their effects. The researchers hope that by observing the eruption, they can gain new insights into the effects on hydrothermal systems and the nearby ecosystem. Imagine being able to watch a volcano erupt without getting roasted. That's exactly what the Axial Seamount makes possible. The scientists can then track in real time how the seafloor deforms, how the temperature and chemistry of the water change, and how the underwater creatures respond. It's like a live broadcast of a geological revolution. The research findings could also help improve our understanding of how and when volcanic eruptions generally occur. In the future, this could lead to precise forecasts not just for underwater volcanoes, but also for their fiery cousins on land. Imagine if one day we could predict volcanic eruptions as accurately as the weather. Today, sunny, with an 80% chance of a volcanic eruption in the afternoon. Wouldn't that be something? The upcoming eruption also reminds us just how dynamic and active our planet really is. We often forget that beneath the seemingly stable surface of our Earth lies a hot, bubbling core. Volcanoes like the Axial Seamount are like the steam vents of our planet. They show us that the Earth is alive, constantly changing and evolving. And without these vents, the planet would end up like a broken pressure cooker. And speaking of changes, do you know what else has changed in recent years? The technology for predicting such eruptions. The ability to predict an eruption so far in advance, as is now the case with the Axial Seamount, is, according to geophysicist William Chadwick, pretty unique. Just a few decades ago, such a prediction would have been unthinkable. And that also shows how far we've come in our understanding of the Earth and its processes. Nevertheless, many questions remain unanswered. How exactly does the mechanism that leads to an eruption work? What role do factors like the pressure of seawater or the tectonics of the Earth's plates play? And above all, can we apply the insights from the Axial Seamount to other volcanoes? The answers to these questions could help us better understand volcanic eruptions and maybe even control them one day. Just imagine if we could milk volcanoes, releasing pressure in a controlled way and preventing major eruptions. Sounds like science fiction, but who knows, maybe in a few decades it will be reality, and we could use a giant like Yellowstone to supply entire continents with energy. Or in Germany, we could use the Eiffel volcanism to finally bring electricity prices down a bit. So, the Axial Seamount is not just a fascinating natural phenomenon, but also an important research subject. It's like a huge underwater laboratory where we can unlock the secrets of the Earth. And the best part is, we don't even have to get wet to observe it. So keep that in mind for this year. It could be the year when we witness a spectacular underwater fireworks show. I hope you're all volcano experts now. If you don't want to miss any future updates on American volcanoes, Make sure to subscribe to the channel now and don't forget to give a thumbs up so we can hit 5,000 likes. And speaking of powerful forces of nature, let's travel from the USA to Antarctica. There, scientists have received a mysterious energy signal that can't be explained by any known force of physics. What happened there? And have we possibly found clues to an entirely new kind of physics? You can find out all about it in the video shown at the top right. Be sure to click on it. And if you click at the bottom left, you can stock up on plush planets, black hole cafe items, and the shirts from the videos in the space shop. Every order really supports my work. Otherwise, I'd say we'll see each other in the next video. Take care, everyone.